In this video, I'm going to cover how to decompose a rational like this into its parts. And specifically, and this is important, these are going to be non-repeated linear factors. This does not apply to other sorts of denominators, only denominators with non-repeating linear factors. And here's what I mean by that. When you factor this denominator, you'll notice we get two linear factors and they are not repeats. So this method that I'm going over will work for any denominator whose factors are linear, meaning there's no squareds, and they're not repeats. When we have cases which are repeats, that'll take a little bit of a different technique. We'll go over that in a different video. So I'm going to do two examples. This is one of them, and the second one is right here on the bottom. And you see that's going to look a little more complicated, but the method will be the same. So let's get into it. Now, what we talked about in class was the following. When you do partial fraction decomposition, you have to set it up this way. It's going to be some number divided by the first factor plus some other number divided by the second factor. That's it. And now we just have to figure out what those numbers A and B are. They're not going to be X or delta in this case. They're not going to be variables. They're going to be constants. And the reason they're constant numbers is because these are linear factors. If these were quadratic factors, that would not be true. But we're not talking about quadratics. We're keeping this discussion to linear factors. So let's solve this equation. And the way I'm going to do that, let me just do the following. I'm going to put this over here. Actually, I'm going to take this part. And let me just move that over here, paste, great, like that. I just need a little more room. Bear with me. Just another moment. All right. There. Now, the way I'm going to solve this is by multiplying both sides by those factors. So in other words, I'm going to multiply both sides by this thing. And I'm also going to multiply both sides by this thing. I can get away with that because this is an equation. There's an equal sign in there. Now, when I multiply both sides by both factors, they disappear from the left side. So all I get is this, negative 11 delta minus 5. When I do that to the right side, one of them disappears, the 3 delta plus 1, but I multiply by a factor of delta plus 1. So I get a times delta plus 1. I don't like that a. Just give me a moment here. There we go. And then on the right, when I multiply by both factors, delta plus 1 disappears, but I get an extra factor of 3 delta plus 1. So this becomes b times 3 delta plus 1. You should be comfortable with factoring and solving equations at this point if you're doing partial fraction decomposition. Now it's a matter of solving this. And the easiest way to solve these sorts of things, there's a variety of ways, but what I like to do is something simple like this. I'm just going to say, hey, let's just set delta equal to negative 1. Why did I pick that? Because I can see it's going to cause a 0 to appear. Watch what happens. Negative 11 times negative 1. Okay, I'm just setting all the deltas equal to negative 1. And here's why I chose negative 1. When you do that right here, look what happens. Delta at negative 1 causes this part to disappear. That just goes to 0. And I get b times, 3 times negative 1 is negative 3 plus 1. Simplify this a little more. We get 11 minus 5 equals, negative 3 plus 1 is negative 2, so negative 2b. So that means 6 equals negative 2b. So that means b, if I divide both sides, equals negative 3. Okay? And if b equals negative 3, I can then plug that back into my equation and find a. Or I could do it a little differently, and I could try this all over again and find what happens if I set delta equal to negative 1/3. Right? If delta equals negative 1/3, then this part will cancel out, and so on. So that's the way you solve this. And once you get b, or once you get a, then you can plug that into your equation right here. So my answer would be literally this thing with those b and a values plugged in, except instead of b, I would simply say -3 instead of a. I'll leave that for you to solve what a is. Let's go ahead and do this one. So at first this looks harder, but we're going to do the exact same technique. I'm going to separate this into partial fractions. We're going to have a over delta plus b over delta plus 5 plus c over delta plus 3. They're all constant values, the a, b, and c, because, again, these are all linear factors. And now I'm going to multiply both sides by every single one of those denominators. So on the left side, the denominator just disappears. Everything cancels out nicely. Let's see if I can just write this correctly. There we go. On the right side, we get a times delta plus 5 times delta plus 3. Okay. In the middle, we get b times delta plus 3. And on the right, we get c times delta and delta plus 5. That's the result of things canceling out when you multiply both sides by all three factors. And now what you want to do is you want to set delta equal to some well-chosen points. In the first case, I'm going to say delta equals 0, because I have my eye on these things right here. I think those are going to cancel out nicely if I set delta equal to 0. What you get is the following. On the left, you get -15, right? Everything else is just zeros. See, these guys cancel out. -15 equals a times 0 plus 5, 0 plus 3. So in other words, a equals -1. Okay, great. That's one solution. Next, we're going to pick another well-chosen delta value. And why don't we say delta equals, I don't know, -5. That looks like another one of those zeros right here. Okay, so when you do that, this one's going to be a little more complicated. We get 3 times -5 squared plus 8 times -5 minus 15. That's the left side. And that's going to equal to, well, this one cancels out, so there's no a's. This one cancels out, there's no c's. All you get left is the b. b times -5 times -5 plus 3. Okay, we've got some work to simplify this. This becomes 75 plus, well, that's 8 times -5 is -40. And then minus 15. And that's all equal to, I think 10b. Double check me on that. -2, 10b. Okay, that looks good. So 75 minus 15 is 60, minus 40 is 20. So I get 20 equals 10b. So then b equals 2. All right, we're making progress. And if you do the same thing, I'll let you work through this one on your own. I've already used purple. Let's switch to blue. If you were to do the same thing and say, what's my last interesting denominator, it would be this delta plus 3 thing that we have not chosen yet. If you say delta equals -3, that's going to tell you what c is once you work through it. And in this case, yada, 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 you're going to get led to c equals 2. So you take these three values and you plug them in right here. C equals 2, b equals 2, and a equals -1, and that would be your solution. This is the method that we use to partially decompose this into its partial fractions.